Governance is what keeps a Besu network trustworthy after launch. It defines who can participate, who can validate, how changes are approved, and how risks are handled. In this module, we'll look at the governance models enterprises and consortia use to operate Besu networks with confidence. So far, we've covered Besu fundamentals, enterprise network design, smart contracts, and decentralized applications. Now we shift from building the network to operating it responsibly, with governance, security, monitoring, compliance, and shared decision-making that keep a production network trusted. In a Besu network, the hard part is rarely just running nodes. The bigger challenge is coordinating organizations with different incentives, compliance duties, and risk tolerance. Governance turns a technical deployment into a shared operating model. It defines membership, validator rights, voting rules, upgrade approval, and accountability. Without it, upgrades can stall, disputes can grow, and trust can weaken. With it, participants understand how decisions are made, how risks are handled, and why the network can endure. For a consortium blockchain, governance acts as the operating system for trust. The charter defines why the network exists, who can participate, and how decisions are made. It also needs practical detail: who validates, who funds operations, who handles incidents, and who coordinates compliance. Strong governance covers disputes, escalation, and entry or exit rules. Without these foundations, technical consensus may keep working, but organizational consensus can fail under pressure. A Besu consortium works best when authority and accountability are explicit. Sponsors define the business purpose, funding model, and strategic direction. Validators and node operators keep the network running by maintaining infrastructure, availability, and consensus participation. A governance board makes major decisions, including membership, policy changes, and upgrades. Specialized working groups turn those decisions into recommendations across technology, operations, audit, legal, and compliance. The goal is simple: everyone knows what they decide, what they operate, and what they escalate. Good governance is not only about who gets a vote. It is about matching each decision to the right approval model. Routine operational choices may belong to a manager or delegated committee because speed matters. Major economic, legal, or technical changes need broader consent, higher thresholds, or even unanimity. The rules should also define quorum, abstentions, tiebreakers, and emergency exceptions, so decisions remain legitimate without slowing the organization down. Participation should be managed as a life cycle, not a one-time approval. First, the network defines who is eligible: members, validators, app providers, users, and service providers. Permissioning then turns those decisions into controls over node access, accounts, and transactions. Before access is granted, onboarding verifies legal agreements, compliance, security posture, and technical readiness. Offboarding matters too. Access must be revoked, keys rotated, permissioning lists updated, and audit evidence preserved. Governance only works when decisions have clear owners. Operational committees turn high-level approvals into standards, runbooks, reviews, and coordinated releases. The technical group protects architecture quality and upgrade discipline. Operations keeps nodes reliable and incident response ready. Legal and compliance manage regulatory constraints, data handling, and membership terms. The steering committee connects these efforts back to business priorities and resolves conflicts that individual groups cannot settle. Together, these groups make the network governable day to day. Validator governance focuses on who can influence consensus and under what conditions that privilege can change. In a Besu network, eligibility should reflect trust, technical capability, geographic diversity, and security maturity. Onboarding should verify infrastructure, keys, monitoring, backups, and operational readiness before a node begins validating. After that, performance and incidents need continuous oversight. Removal rules should be explicit, covering downtime, compromise, misconduct, legal issues, or voluntary exit, with approvals defined in advance. Choosing validators is only the starting point. Validator governance is an ongoing control loop. Rotation spreads responsibility and helps prevent one member from becoming too central. Monitoring detects signals such as downtime, missed blocks, delayed patches, or key compromise. When thresholds are crossed, the response should already be defined: warn, remediate, suspend, penalize, or remove. The aim is accountability without chaos, preserving consensus safety while keeping business applications running. Consensus governance is where technical choices become trust decisions. In Besu networks, mechanisms such as QBFT, IBFT 2.0, or Clique define how blocks are finalized and who participates. Changes to validators, block time, epoch length, gas limit, or upgrade timing require more than approval. They need technical review, risk assessment, coordinated scheduling, and post-change validation. The key principle is consistency. If validators apply different configurations, block production can stall, or the network can split. Every Besu change should follow a controlled lifecycle. Start by classifying the request as standard, normal, major, or emergency. Then assess impact, obtain the right approvals, and validate in a testnet or staging environment whenever possible. Production deployment should occur in a defined release window, with stakeholders informed and a rollback plan ready. Afterward, confirm network health, document what changed, and capture lessons for future upgrades. Smart contracts are not just code releases. They can change shared business rules, so governance needs to cover the full lifecycle. A commit should pass automated tests, security review, and business approval before deployment. Upgrades need clear patterns, including proxies, versioned contracts, migration scripts, and backward compatibility checks. Teams also need emergency controls: who holds admin rights, who can pause execution, how incidents are handled, and when an old contract is formally retired. Emergency governance is the consortium's fire drill. If a validator key is suspected compromised, the rules should already define who detects the issue, who must be notified, who can suspend the validator, and how keys are rotated. That authority should be narrow and time-limited, with an escalation path and a written record. Disputes should follow a separate resolution process, not ad hoc politics. Once stability returns, the incident review turns lessons into stronger controls. Governance turns a Besu consortium from shared infrastructure into a trusted enterprise network. Clear roles, validator controls, and disciplined change management protect consensus, reduce operational risk, and keep the network adaptable. Next, we'll connect these governance foundations to compliance, security architecture, monitoring, and emerging AI considerations.